Namaste and welcome back to JEE Physics with Typical Monk. This is class 23, Ray Optics and Instruments. Last class, light was a wave filling all of space. Today we tame it into rays, thin straight lines that reflect off mirrors and bend at boundaries. From just two simple laws, the angle of reflection equals the angle of incidence, and Snell's law of refraction. Flow mirrors, lenses, the critical angle, and every optical instrument from the microscope to the eye. One sign convention, two formulas, and the whole chapter opens. One idea at a time. Here is what you will master today. First, reflection and the mirror equation. Second, refraction and Snell's law. Third, total internal reflection and the critical angle. Fourth, the lens maker's equation and thin lenses. And fifth, the optical instruments plus the drill suite. One idea at a time. 4 ideas. Run this entire chapter. Look at them together first. Rays, light travels in straight rays. At a surface it reflects, and at a boundary it refracts. Reflection. The angle of incidence equals the angle of reflection. And mirrors obey 1 over V plus 1 over U equals 1 over F. Refraction, Snell's law, N1 sin I equals N2 sin R. Light bends toward the normal when it enters a denser medium. Master line, one sign convention and two equations, the mirror and the lens, unlock the whole chapter. Now look at the picture. Refraction and total internal reflection. Refraction, crossing from a denser into a rarer medium, the ray bends away from the normal. The critical angle. At one special angle of incidence, the refracted ray grazes along the surface at 90 degrees. The formula. That critical angle obeys the sine of theta c equals n1 over n2, the rarer index over the denser. Total internal reflection. Beyond the critical angle, all the light reflects back inside the denser medium, the principle of optical fibers. Now the spherical mirror. The mirror formula. 1 over V plus 1 over U equals 1 over F, with every distance measured from the pole by the sign convention. Focal length. For spherical mirror, F equals R over 2. Magnification. M equals minus B over U. A negative M means a real inverted image. Concave versus convex. A concave mirror can form a real or a virtual image. A convex mirror forms only a virtual, erect, diminished image. Now, refraction in more depth. The refractive index. N is the speed of light in vacuum, divided by its speed in the medium, always at least 1. Snell's law. N1 sin I equals N2 sin R, and this product stays constant across the boundary. Which way it bends? Into a denser medium, the ray bends toward the normal, into a rarer medium, away from it. Apparent depth. A pool looks shallower than it is. The real depth over the apparent depth equals N. A spherical surface. Refraction at a curved surface links the object and image distances through the two indices and the radius. Now look at the picture. Image formation by a convex lens. The 3 rays. One goes in parallel and then through the far focus F. One goes straight through the optical center and one goes through the first focus and emerges parallel. Where they meet, their point of intersection locates the image. Object beyond 2F. The image is real, inverted, and diminished, lying between F and 2F. The lens formula, 1 over V minus 1 over U equals 1 over F with the magnification M equal to V over U. Now the equation that designs a lens and its power. The lens maker's equation. 1 over F equals N minus 1 times 1 over R1 minus 1 over R2. It links the focal length to the glass index and to the two surface radii. Power. P equals 1 over F with F in meters. It is measured in dioptries. Positive for a converging lens, negative for a diverging one. In contact. For lenses placed in contact, the powers simply add P equals P1 plus P2, and so on. Everything. The mirror and lens formulas plus the sign convention solve every optical instrument. Now, Optics at work. The instruments. The simple microscope. A single convex lens. Its magnification is m equals 1 plus d over f. The compound microscope and the telescope. Each uses two lenses, an objective and an eyepiece, multiplying the magnification. The eye, a living convex lens, focusing by changing its own focal length, a process called accommodation. Now match each formula to its name. n1 sine I equals n2 sine r goes to Snell's law. The sine of theta c equals n1 over n2 goes to the critical angle. 1 over v minus 1 over u equals 1 over f goes to the lens formula. And 1 over f equals n minus 1 times 1 over r1 minus 1 over r2 goes to the lens maker's equation. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. Light bends toward the normal when it enters a denser medium. Correct. Statement 2. Total internal reflection happens going from a rarer to a denser medium. Wrong. It is the other way, denser to rarer. Statement 3. The power of a lens is 1 over f in meters in dioptries. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the direction of total internal reflection in statement 2. Now the two mistakes that quietly cost marks. The truth, total internal reflection needs light going from a denser to a rarer medium, beyond the critical angle. The trap, mixing up the sign convention, always measure from the pole, with the incident direction taken positive. The second truth, the lens maker's equation is 1 over f equals n minus 1 times 1 over r 1 minus 1 over r2. The second trap, using 1 over v plus 1 over u for a lens, the lens formula is 1 over v minus 1 over u equals 1 over f. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. Snell's law. n1 sine I equals n2 sine r. Question 2. The critical angle condition. The sine of theta c equals n1 over n2. Question 3. The lens formula. 1 over v minus 1 over u equals 1 over f. Question 4. A mirror's focal length in terms of r. F equals r over 2. And question 5. The power of a lens and its unit. 1 over f in meters. And the diopter. Let us gather it all in one breath. Reflection, I equals r. The mirror formula, 1 over v plus 1 over u equals 1 over f, with f equal to r over 2. Refraction, Snell's law, n1 sine I equals n2 sine r. Light bends toward the normal into a denser medium. Total internal reflection, denser to rarer beyond theta c, the sine of theta c equals n1 over n2. The lens formula, 1 over v minus 1 over u equals 1 over f, and the lens maker, 1 over f equals n minus 1 times 1 over r1 minus 1 over r2. Power, p equals 1 over f in that place, and powers add in contact. Next class, wave optics, Young's double slit, and diffraction. Reflection and refraction, just two rules, and light does everything. It bounces from mirrors, bends through lenses, hides inside a fiber by total internal reflection, and builds every instrument, from the microscope to your own eye. Keep the sign conventions steady. Remember the mirror and lens formulas, and every ray-chasing problem becomes simple bookkeeping. Next class, light remembers it is a wave again. Interference and diffraction. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.